Well, thank you very much for stopping by the SUSE booth. It's my distinct pleasure to talk about what we're doing with SUSE and with respect to Singularity containers. First of all, a little bit of terminology. I've used the phrase up here, enterprise performance computing. Now, obviously, this is all about high-performance computing here at supercomputing. In this particular instance, SC18 here in Dallas, cold Dallas. What we have been finding, working with our partners like SUSE, is that there are a lot of organizations who aren't in the sort of traditional government educational space who have very compute-intensive demands. And so because they have more of this enterprise spin to them with more enterprise-grade requirements, we've coined the phrase enterprise performance computing. And what I'm going to try and do in the next just couple of minutes before we do other things here in the SUSE booth is tell you a little bit about why we think we've got a great fit here. So first and foremost, there are other solutions out there that offer containerization, but Singularity really is different. Singularity has its roots right here in the HPC community, okay? So first of all, what really distinguishes Singularity is its simplicity. Actually, we've got some wonderful marketing lines on this. It's simple, it's fast, and it's secure. But actually, those phrases really have real value. Simplicity at the outset has to do with the fact that the container runtime is encapsulated into a single file. We use something called Singularity image format, which was released formally as part of the 3.0 release of Singularity back just really last month. And that encapsulates all of the runtime. So what this means is that many times when you're thinking about making use of Singularity for containerization, all you have to think about, if you understand something about file systems, you already understand something about containerization via Singularity. So Singularity containers run in user space, which means that accessing special purpose devices such as GPUs, InfiniBand interconnects, and so on is actually very, very simple. It's also secure because, again, we've got that very simple paradigm where the container runs in user space. So, for example, there's no opportunity for privilege escalation. If you can be root outside a Singularity container, you can be root inside a Singularity container. But if you can't be root outside, you cannot escalate your privileges inside. So we've also really simplified the security paradigm. I'm going to talk more about how we see things moving forward and broader-based integration efforts, and I'll come back to talking about the Open Container Initiative and Kubernetes a little bit later on in the presentation. So in terms of one slide, I already alluded to the fact that being able to access GPUs is actually extremely simple. You really don't need to do any heavy lifting. In other words, once you have got your application running in a non-containerized fashion, for example, you can pretty much do the same kinds of things from within a container. It's really quite simple. I'll give you a little bit of a better example about that later on. I'm going to say more about standards compliance a little bit later in the presentation. We integrate with all the different workload managers as well. The folks from Altair were here just before me, speaking about PBS. That's another one that could be added to the list there. Talked a little bit about security. The other key thing I should say about Singularity containers is there is the ability with this, and really this is also associated with this new image format, SIF, Singularity image format. We have the ability to sign containers and then to validate the signatures. So if you, for example, give me a container, which would be very kind of you, thank you, then what I can do is ensure that nobody has tampered with that container in transit, as it were. So that's, and that's of course all cryptographically verified and so on. So really, those are some of the key things I just wanted to highlight from this slide. Now, if you are using SUSE Enterprise Linux, one of the ways that you can get Singularity releases is from the SUSE Package Hub. Okay, what you'll find there today are right up to the 2.6 release of Singularity. Sylabs and the Singularity community are actually working with SUSE to make available the version 3.0 release. which, as I say, just came out literally last month. So that's a great way to take your SUSE Linux Enterprise server platform and rapidly add Singularity capability to that. Okay, so that's just to make it very clear. So here's an example that I alluded to before. Hopefully you can see some of the fine print here. One of the really interesting things about Singularity is it has a high degree of interoperability with Docker. And that's because Docker really established a lot of the sort of mainstreaming of container technology. There's a lot of investment that people have made in building Docker images and so on. So the great news for anybody who wants to use Singularity is that you can actually, as easily as specifying an image, in this case it's for the TensorFlow deep learning framework, it's coming right from the Docker hub. You can grab that existing Docker image, make it available locally, and then actually execute it directly via Singularity. This example is also showing how we can tap into GPUs, and in this case, using the Python capability that's inherent in TensorFlow. So basically what you can see here is we're executing this Docker container, and we're executing Python within the container. So now here, these are all Python programming syntax entries here. So you're basically importing TensorFlow, doing some assignment statements, doing some simple manipulation, in this case some multiplication, producing some results. So really all I was showing you here is that it's literally this easy to take an existing image, in this case one that's provided by Docker, to tap into the GPUs that you have available and be very quickly up and doing some effective deep learning using a very modern framework. Now, what we've been doing is within Sylabs and the broader Singularity community is we're now at the point where Singularity's sort of developed enough traction and interest and so on that we're trying to make sure that there's a lot of examples available to help people get up to speed very quickly. So you can go to our this particular area of our GitHub site. So basically, that's the main sort of GitHub site for Sylabs. You can clone Singularity from that location. It'll be a Sylabs Singularity location. This is where all the examples are. You'll find examples, as we say here, for everything from different kinds of databases to graphics examples. Even really interesting stuff such as Internet of Things examples. We've done some recent work with Kontiki, for example. All kinds of languages, and there are a whole whack of machine learning examples that you'll find there, including various frameworks such as, Caffe and TensorFlow and so on. Another very interesting example that is up there as well is something that came out of Uber called Horvath. And some of you may know about this. What we're seeing is that, and it's actually a pretty good segue into the next slide. Actually, maybe this one here. What we're seeing is that, as your machine learning activities, your deep learning activities, as they become successful, as you go from prototyping into production, quite often you'll start to run into bottlenecks. And so very often what people are doing is, of course, introducing distributed processing to help take advantage of parallelism, to split out, for example, very intense distributed training capability or requirements. Horvath is a very interesting framework that basically uses MPI, and it will enable a number of different frameworks, TensorFlow, PyTorch, and there's at least one other one that for some reason is escaping me at the moment, but it enables those frameworks to take advantage of a distributed environment, and you can do processing in that way in a parallel fashion and really speed things up. So in and of itself, we see a lot of interest in that kind of thing, and of course all of this is running in Singularity containers. Now, what I'm showing here on this slide are is basically, I like to think of it as almost a new paradigm, a new pattern for a whole series of use cases. And so what's quite often happening is that you have a training requirement, which we can see here is up at the top. And you may be using something, what we've seen is a number of examples where people are using a capability from Kubernetes called kubeflow, and then you might make use of some workload manager. The particular example here relates to Slurm, and the two are used to facilitate basically the distributing out of these training tasks that need to happen. The images, the container images, are increasingly being leveraged from our new Sylabs cloud, where we actually have the ability to store these pre-built containers. And of course, what this also really amplifies is a point that I didn't make strongly enough before, but one of the key attributes of containerization by Singularity is that you make your runtime extremely mobile. But also, very important for anybody who cares about doing responsible science or engineering, is reproducibility. So by having a consistent runtime environment that is consistently shared, signed and verifiable and all that kind of stuff, what it means is that when you do your distribution, you can be very assured that you're getting consistent results as you spread the work across a number of different processing compute nodes, whether those instances be based on the ground or in the cloud running SUSE Enterprise Linux, for example. Now, the bottom part of the slide has to do with, in fact, the need to run deep learning models. And what we're seeing more increasingly now is not only a requirement to, of course, be incorporating data, but in fact to be ingesting that data in real time, quite often using some kind of a streaming capability. So a lot of the use cases that we're seeing now are using, it is in fact on the slide, they're using Kafka as a way of helping to facilitate the streaming, the ingestion of that data in real time, and of course at the kinds of volumes that you might expect from, for example, social networking services like Twitter, what have you. So all of this needs to happen, be orchestrated, and what we're finding is, again, that people are using workflow tools like Nomad, along with Kubernetes. Kubernetes is a great way of building container clusters. And actually, if you want to know more about Kubernetes, the SUSE folks have a very cool video that teaches you about Kubernetes in a fun and amusing way. but it's of course, is technically accurate. Anyway, what we're seeing then is a need to put all of this together. And again, the Sylabs Cloud is kind of like the glue in between, providing access to these images in a way that facilitates a securely available image that promotes the highest degrees of mobility and also high degrees of repeatability when you do the calculations again. So we're seeing that Singularity can bridge what we think of as being kind of classic HPC or enterprise performance computing problems in the upper part of the slide with more services-oriented computing that we're seeing as people start to embrace Kubernetes. So what that also means then is that this final slide talks about how we see a need to kind of address a lot of these requirements that have started to emerge from within the Singularity community in some of the software implementations that we're starting to put forward. So we've already made announcements here at the show about how we are starting with OCI compliance. So OCI stands for the Open Containers Initiative, and so they are the entity that is trying to drive towards standards for containerization. And right now they're focused on two areas, not too surprisingly, something to do with the format of the container images and something to do with the container runtime. So what we're going to be doing is, as a great proof point of our new Singularity image format, we're going to leverage its extensibility, its properties, its capabilities for extensibility, and use that to draw it into compliance with the OCI image part of the compliance requirement. And then the second part is we'll also be doing some work to ensure that everything from Singularity APIs, command line interfaces, and so on are all appropriately compliant with the runtime piece from the Open Containers Initiative. And then, of course, the second piece that is, I think, quite exciting is we've already got really well underway, even more underway than we've been sort of suggesting, perhaps, the ability to interface very tightly between Kubernetes and Singularity. Basically, now the idea is that if you've got a kubelet, for example, running as a Kubernetes agent on an arbitrary node in your cloud, in your cluster, what have you, that kubelet because we're basically building a gRPC, so this is the remote procedure call capability, we're building that server capability for Singularity. So now you'll be able to go directly from a kubelet and be able to invoke Singularity containers directly. So this will really help to enable that use case. Our interoperability with Docker continues. We are going to be able to support the Docker file syntax directly. That's one thing we haven't got in Singularity currently. So in case you don't know what this is, you can basically, using a simple text file, you can specify essentially a build sort of manifest for Docker. And of course you can do that through a Singularity definition file. What we will be able to do now is to work with that directly and in a variety of different ways. And one of my colleagues has been working a lot with HashiCorp's Nomad. Again, a tool, a technology that enables orchestration of workflows. And we have a plugin for that will become available pretty soon. So there's lots of exciting stuff going on, even though this 3.0 release, as I say, is barely a month old. The big sort of wins there were we actually re-implemented the core. Sylabs re-implemented the core of Singularity using the Go programming language. Part of our rationale for doing that is because it helps to set us up for integrating better, more effectively with the rest of the sort of growing container ecosystem. So that was a good thing. And then we introduced this Singularity image format that I've been also telling you about. But we're not resting on any of those laurels. We're very hard at work on a number of other very exciting initiatives. And I think with that, I am done.
All right.